Ladies and gentlemen, this is Joe's Classic Video Games back with another cool pinball repair video for you this evening. We have been working on this complete basket case Bally Supersonic pinball machine. There's no way yours is in worse shape than this one. But we've been steadily working through it. This thing had a fault where the 43 volts that runs the solenoids and runs the zero crossing detector on the MPU was shorted to the 5-volt line in the MPU. And by doing that, they fried every chip in the game, we believe. We don't know about the displays yet, but when we bought it, our buddy Jonathan got it for us. When we bought it, the lamp board was missing and the solenoid driver board was missing. The MPU was still there, the soundboard and the displays in really rough shape. So today we are going to repair that MPU board. What do you think? Don't even know if it's possible, but we're going to try it. The reason this board was missing is because this is the board that turns the 12 volts into the 5 volts. So whenever that board shorted, it would have tore this all to hell. And then the lamp board has a bunch of chips on it that I guess it must have been obvious on the board that some of them had blown up or been damaged. Here is the soundboard. Notice the one chip has been burnt, the other chip has a big hole in the middle of it. It's a shame too because this prom here is very, that's kind of what you have a trouble finding because that has to be burned on a one-time burn prom, right? So in other words, I can't do it myself, I had to order it from somebody. The other ones are just chips that you can replace, so it's not that big of a deal, but that one kind of sucks. And it's not crazy, it's like 20 bucks or something. And they make new replacement boards. Our buddy GTO makes a brand new board for it. But anyway, today we are going to work on that MPU. So we have done the rectifier board, the transformer, all the voltages are correct here. They then travel up to here, the 12 gets turned into 5, that is correct. The 240 or whatever gets turned into 190. We've got it set at 180, so it's a little lighter on the displays. So this board is working fine. We pulled that out of a parts box. It had a bunch of stuff missing, put it all back together. So if you didn't see that video, it was really cool. You ought to check it out. But now we're on to the MPU. So let me show you what's left of the MPU because it was burnt up, and then I burned it up again because I didn't know that the line was shorted on it. Oh boy, we got our work cut out for us. Let's check it out. If you've been following the saga of the Workbench, there's that screwdriver I lost. All week long I've been trying to clean off my Workbench, and I have it cleaned to where I can barely reach everything on it. Like, I can't quite, you know. So that's pretty good. It's getting there, but I want to go farther that way. Keep going that way. Okay, so this is the board that was in it. Now, when we first started the videos, this smoke damage was here already. So this had already caught on fire. Now if you look, the chip has completely like just melted down. Big problems. Okay? So I thought, well, a chip burned up, we'll figure out what's going on with that, blah, blah, blah. And we were working on the rectifier board. And I was trying to, you know, on the transformer. And I was just trying to get the thing to work. And we got it all working fine, and I plugged everything up. Sparks everywhere, fire. It was like brimstone and hell. It was horrible. And when all was said and done, it blew a fuse and caused this smoke damage, this fire damage. So the 5th pin up here was shorted to the 4th pin up here. The 4th pin up is 5 volt, the 5th pin up is 43 volts. So every chip runs off 5 volts, but instead of getting 5 like they wanted, they got 43. So wham! It was not happy. Big problems. Okay. I've worked on a lot of these, so I think we can fix it. Now, the damage here, it was from the battery that's mounted here, and that's typical on these Bally 35 boards. The part number ends in 35, so they call this the 35 board. It's silk screened right there, but you can't read it because of the corrosion. So this one looks like it's real bad. It's not that bad compared to most of them. Most of them, this corrosion rises up to like here and eats a whole bunch of stuff. This one, the corrosion has only got up to like here. It's not that big of a deal compared to how they usually are. This is just cosmetic. So we're going to do the whole thing on this like we usually do, and see if we can fix everything that got smoked. Now, oh, and let me show you the back. This is another reason I kind of want to work on this particular one, because the back's fine. So the place where the fires were is fine. It didn't burn up the board. It's just kind of superficial stuff. This one's in pretty good shape compared to a bunch of them that we get. Now you can buy a brand new board for it. They're like $200. It's not that big of a deal. But I thought it would be kind of cool to fix the original board. Here's you some more horror footage. Yes, that's a big hole blown out of our ROM. What do you think about that? That's fun, right? Yeah, that one won't work anymore. When it does that, folks, it ain't working anymore. Look at this one, how it's cracked in half. Yeah, when it does that, big problems inside. Okay, so, but if you think about it, running 43 volts through a socket, the socket's probably fine. We'll look at the pin that it runs through. But this is socketed, this is socketed, this is socketed. This is the 6800 CPU. These are 6821 PIAs. You just pop them out of the sockets. This is the 5101 memory for the CMOS, like the battery backup, basically, for the high scores and settings. And not even all the settings, just actually on Supersonic, none of the settings. It just saves like bookkeeping information and the high score. This is the 6810, which is the RAM for the CPU and the ROMs. This is a ROM, this is a ROM, this is a ROM. All those are in sockets. So they might not need much work. This is a 555 timer, super common chip, no big deal. And so then that leaves us with 1, 2, 3, 4, 5, 6, 7 chips. Well, 8 chips. 8 sockets if we have to replace everything. So it's not that big of a deal. It's that what are y'all worried about? I don't understand what's the big hang up about this thing? Well, we'll check back at the end of the video and see if I was right. But there was other damage. So there is a cap here that is blown apart. That is a mylar cap, not a mylar, a tantalum cap. But the thing is, it's right in the corrosion area. You always have to replace that anyway. This here, we might have to replace these. I've got all that. We need to certainly clean all that up. This transistor, usually you have to replace. This is all part of the reset section. The 5101 and its socket, usually you have to replace. So that's not a big deal. This resistor damage here is just heat from this. Very common. It's on most of them, and that chip usually survives it. Although that chip's probably dead now because of the 5-volt thing. I might have got lucky and like this cap blowing up or something. I think the 5 just directly connects to all of them. But I might have got lucky and there's a cap blew up or something that saved some of the chips. And this up here is like clock stuff. And another cap. So what we're going to try to do is, I'm going to take off everything and clean it up. Not everything, but everything that I need to. And clean it up. And I'll show you as I go through what I find that's messed up. We'll look at it in the schematics. And I think we can kind of check off everything that the 5 volts goes to on the schematics, where we can either check to see if it's fine or go ahead and replace it. And then we also have to clean up the battery damage while we're at it. And then we'll start repopulating it. And the way these things work, some of these chips are involved with like making the displays work. Well, we don't need those to work yet. We just need the game to boot code. So we need the CPU, the PIAs, the RAM chips, and the ROMs. So this, which includes the clock and the 555, all have to kind of work to get the flash code to work. There is a little LED right here that will flash a code as it goes through the boot up process and tell you what's right and what's wrong. So there's a sequence of 7 flashes that it does, and it tells you where you've got a problem. And then these other ones, maybe, I don't know about that one. We can look it all up, but these other ones, some of them aren't completely necessary to get it to boot. but of course they'll be necessary for the game to run, and for the displays to work and stuff. So, like everything, the way you handle a big problem, this is certainly a big problem, is you just do it a little bit at a time. So the first thing I'm going to do is I'm going to remove this socket, because we're going to have to replace it anyway. And we're going to start cleaning up this battery damage, because that's in my opinion, the most significant thing that's wrong with it. So yeah, so we'll start with that. And as I run into stuff, I'll make a little pile of stuff that was obviously fire damaged, and we'll see if we can clean this soot off. This stuff can be conductive, so you don't really want it to stay like that because it'll cause a short. But yeah, so hopefully at the end of the video, we'll have a completely working MPU. Here we go. Okay, folks, so what I do is I take a wire brush and I just go to town on it whenever it's got the corrosion on the bottom of the board like this. I just go nuts on it. Now, that has the effect of breaking some of this stuff down here. But if it breaks, you shouldn't have left it on there anyway. It was compromised. So, like, see this resistor here? I've now broken the leg off of it by just hitting it with this brush over and over again, right? But that just told me that this resistor was pretty weak. I did the same thing to this cap and it didn't break. So that cap's probably fine. Same here. Same here. You can see where I've actually removed some of the, you just saw how this was all blackened, right? I've actually removed some of the coating on the resistor, but it didn't break because it's still fine. It was just dirty, right? This one did break. So you're not really losing anything by doing that. Yeah, you're going to break crap off the board, but it was all compromised anyway. It's a good way of being able to tell. You know, we know this resistor that I just went nuts on enough that I sanded all the black off of it, right? We know that thing is physically still in good shape because it did not break, even though the one next to it did. So that's just my philosophy on it, right? And just go nuts on getting all of that off. Now, you can see that the corrosion is really still there. But most of the actual, like the buildup and everything is gone. Right? And that also, you can kind of see how it spreads. So the battery was here. It spreads over this way. These were the power lines. It usually doesn't go all that high over on this side. But for whatever reason, it goes real high on this side. And once it'll kind of go up this ground trace. And then it'll start eating these. You know, but it hadn't got to that yet. So it wasn't on a scale of like 10's the worst I've seen. This is like a 4. It's not that bad. So same thing on the back. You're just trying to get as much of the actual physical buildup, and it'll build up off of the board, just all of the corrosion. So you're just trying to get rid of all of that. Another thing is, if you're like, we're going to remove this this chip. Solder will not stick to this corrosion here. So that's another thing. We're trying to get it as shiny as we can so that the solder can actually work on it. So next up, I'm going to try to remove this chip. Okay, folks, so after getting everything cleaned out and everything, you can see the extent of the damage. Several of the traces no longer connect to the holes. Almost all of the pads on this bottom row are gone. And the back is just as bad. So I'm going to clean this up a little bit, and then I'm going to use a socket. I'm going to go ahead and put the socket back in. I'm not going to use one with a frame. I'm going to use some of the inline sockets so that I can solder to the top and the bottom wherever I need to get a trace connected to it. Okay, so I've been pulling off some of the damaged items, and I've been checking all of the stuff that's on the board. These are the ones that are testing a little weird, but I'm not sure if it's because of the shorted chips or not. I'm cheating. There used to be a place called Great Plains Electronics, and they sold a little kit to rebuild the reset section of the board with, and it had a convenient little list of all of the stuff down there in the bottom of the board. It had a convenient little map of the board, and it had a convenient little parts list of the whole board. So I've been using that to check everything. Now I got to say, this socket was one of the most screwed up sockets I've seen on any of these boards, and the damage wasn't that bad. So I don't know what the deal is with this particular one, but it took a while. So it sure as hell ain't pretty. But basically, whenever I took the old one off, corrosion had just completely ate up all of the pads. So most of the pads were missing on this bottom row, and especially on the back. But I got it in there, and I've been putting jumpers and soldering and blah, 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 just making sure every single pin is connected and checking it over and over and over again. And I had to solder on the top in some places, and I had to solder on the back in some places and put jumper wires. Let me show you that. We have 4 jumper wires on it. Whew, lordy, that's ugly. But I think it's going to work. I still have to address this a little more. As I go through each part, I'm getting rid of all of the corrosion. Then I'm going to give it a vinegar bath and all of that. That's coming. But we're getting there. So I'm going through piece by piece by piece by piece. And I started working through here. I was able to clean up that soot off of the board in this area where it was all black. I was able to clean it off. I scrubbed it with some just some Clorox, basically, like cleaner with bleach, and cleaned it up as best I could. Was able to get that off. I haven't messed with any of this yet. And I went through each component and checked it against the chart, what it's supposed to have. All right, I've replaced a cap, a resistor, 3 transistors, and everything else seems fine at the moment, but we'll see. I also replaced the cap up here. Both of those were across the 5 and the ground, so of course they just blew all to crap as soon as they were fed the wrong voltage. So next up, I want to remove the chips in the socket, and then I'm going to start desoldering the chips that are on the board. It's safe to say every one of those is going to be fried. So I'm going to remove every one of them and put a socket in its place. So that's next. All right, folks, so I was able to remove the timer. This one, this one, this one, this one, this one, this one, and this one. Also, after I did that, I checked all of the resistors and stuff that I had that were measuring weird in circuit. And these 4 no longer measured weird in circuit. This one still does. It measures 12K. But if I remove it from circuit, it's the correct 120K. So I'm going to look at the schematics just to see why that is. There's probably something in parallel. Well, there's definitely something in parallel with it that's lowering the resistance as measured in circuit. But it's fine, because if I remove the resistor, it's fine. I just want to make sure there's not another short on the board that I'm unaware of, that I'm not catching. I was able to get up most of that soot off of there. What do you think? Looks a lot better, doesn't it? So I'm going to look at the schematics at that resistor, and then I'm also going to look at the schematics, just for giggles, at chip U19, which is this one. This is the one that got the double whammy. It seemed like it popped big time as soon as I plugged it up, and it was already smoked. Remember, whenever we saw the board in the game, this is on your first video, you didn't see it on this video, but on the first video when we saw the game, I noticed that it was smoked and it burned up. And my thinking was, oh, it ain't that big of a deal, they just had some kind of problem. And I went ahead and plugged it back up after I got everything going, and they had it overfused and it smoked again. So it'll be interesting to see why that one seemed to have got it worse than the other ones. Like this one, for instance, didn't even hardly look damaged. There is a little bit of a burn looking mark there. But my guess is that that has something to do with the zero crossing, and that's why that one got it so hard. But let's look on the schematics and see. All right, so the 43 comes in, goes through a resistor, and then is measured as 21. But our problem was it was shorted to the 5, right? So we got 43 on the 5, and it was right here, so it wouldn't have been the 21. It would have been 43. The zero crossing detector is actually U14, which is this chip, which looked pretty good. But if you think about it, we're going to have to go farther into it because this chip obviously, well, no, I was going to say this chip can handle 21 volts, but actually it can't. They lower it again to 4.9 with this diode. But the one that got all the problem was U19, which just gets 5 volts. But it could be the nature of that chip. Maybe that, let's see what U19 is. It's a 4011. So it does not like more than 5 volts at all. U14 is a 4049. So U14 handled it better than U19. Okay, let me figure out that resistor too. All right, so the one that R2 here is supposed to be 120, which it is out of circuit. When I put it in circuit, it's now 12 or something like that. But if you know, the way it's connected through here, I can see why it would do that. You have a resistor here and a resistor here. I don't know if that base would just be connected to the emitter or not, but whatever. You can see where it would be easy for when that's in circuit. If you measured from here to here, you wouldn't get 120K. You'd get whatever power it could get through here and here, giving you your resistance. So I think that's fine. Okay, so what's next? Starting to get scary. Next, we have to figure out what all we need to get the thing to actually boot. So I'm just going to put the minimal chips on it to see if we can get it to boot. Okay, so I went ahead and put sockets in all of them. Starting to look a lot better now. Don't look at just ignore that part. Okay. So the MPU, we all know, is a 6800 made by the great Motorola, also known as Williams Pinball. So we know we need an MPU. Now, this is the PIA, the Peripheral Interface Adapter. Now, the problem that we have is that the displays don't work yet. And the lights don't work yet. So how are we going to know that the board even works? Well, this little LED is going to be our only output. And that LED needs this PIA to turn it on. So that's how we're going to judge if the board is working. We're going to watch this LED. Now this LED runs off 12 volts. So if you power the board with its 12 volts and its 5 volts that it wants, that LED will immediately come on and stay on. If the board actually starts running code, the first thing it does is turn the LED off. So we will know if it's running code if the LED turns off. So it gives like a real quick flicker. It turns on because the power goes to it, and then the board, the CPU immediately turns it off. The CPU will only turn it off though if it's running code. So of course we need a ROM chip for it to start running code. And the very beginning of the ROM code is turn off the LED. So that's how we're going to know. That's backwards. Most people, they don't understand this LED because they have it completely backwards. The LED is always on. If the LED is off, that's only because the MPU is telling it to turn off. So it doesn't necessarily flash. You see it as a flash, but what's really going on is the MPU is turning it off and then allowing it back on and then turning it off again, right? So it's kind of backwards. Once you kind of get your mind around that, it makes it all make a lot more sense. So with that to say, if I were to plug this into 12 volts right now, even with if I took the MPU out, that would just come on and stay on. But we're trying to get it to turn off. That's the whole thing. So for the MPU to start running code, the CPU to start running code, it has a few signals that it needs. So one, it needs a ROM, so it's going to have code to run, which will be in the ROM chip, which goes right here. And these two, but I think this is the only one you need to get it to start. So it has to have a ROM, it has to have a code. It has to have power. And on the 6800, of course, it has to have a clock. So the clock signal we'll look at in a minute. I think it's this chip right here. And it has to have a reset line. So when the game comes on, this pin 40 on the chip is high. It's at 5 volts. And this reset line holds it low to 0 and then lets it go back up to 5. And I may have that wrong. Maybe it starts at 5 and it goes low. Whatever, we'll figure it out. It doesn't matter because it's going to do it itself. But the whole purpose of that is to make sure that this starts at a known state, and it just basically holds the CPU turned off until that reset line goes high, which takes a split second, literally a second split into parts. One of those little parts, right? So the reset section is all this down here. Not this, but all this stuff, right? Or some, I don't know about how much this. Yeah, this too. This and this is the reset section. So you need that, but that's kind of hardwired into the board. You need a clock, and you need a ROM. I don't know if we need this 555. I mean, we could just go ahead and put everything in it, but it's kind of, because this may be the only chance I get to do this, I'd kind of like to get it the minimal amount of stuff that you need to boot it up. So let's see what the clock chip is. Okay, so here's the 6800. These are the outputs, you know, the address bus and the data bus. And so as inputs, it needs power. Pin 40, it needs this reset line, which comes from the stuff we were just talking about. The valid power detector, you know, circuit, right? And then it needs these two clock signals, clock 1 and clock 2. So these come from U15 A and B, which is the part of, you know, the two different sides of U15, and U16. So we need both of those. So we need U16 and U15. Now I want to see what the 555 is doing. It's over here. It is the display interrupt generator. My theory is this thing will run without that. It just, the displays won't work, but we won't know because we don't have any displays anyway. Okay, so let's try we gotta have U15 and U16 definitely. Okay, so U16 is a 9602, which I'm told is a dual monostable multi-vibrator. Yeah, boy. Makes sense. Sounds like some kind of clock something or the other, doesn't it? We've used those before, actually. I actually had one. You know, I think I remember replacing that on a Williams board. And then this one is a 74S37, which I'm told is a quad 2-input NAND buffer. And folks, this is new old stock stuff. I didn't pick that out. You know, I know some of you, you know, this is going to make some of you quit my channel in a rage. After I made that little joke about Canada being the 51st, it was a joke, folks. Come on. It wasn't that, come on. It wasn't that big of a deal. It's just a joke. I didn't mean it. It's just a joke. Y'all, if your buttons are this big, I got to push it. It's going to be all right, folks. Okay, so we got that done. Let's figure out what these are. And then see if we can kind of confirm that we probably don't need them to try to get the flash. I kind of want to see that flash, and I only want to have a few chips when I do it. All right, so U20 is used for the displays, and it's just an output, and there's, you know, there's no two-way stuff going on there. So you don't need that. You just won't have any displays. And then here we have U14 and U19, but they're just using them for the blinking signal. So they're probably used for other things, I would imagine. What else can we get away with getting rid of? U12, like we talked about, we don't need that. Okay, so memory enable. Is that for the battery? The memory enable circuit. I don't know if they're just using that for the battery. Where is our battery? No, the battery is here on the auxiliary voltage to U8. Well, U14, like we said, is the zero crossing detector, but that it doesn't check that till the 7th flash. So I don't believe you'll need that either. So we don't need 17 and we don't need 20 for sure. And we don't need 12. 12, 14, and 20. But unfortunately, I think we need about everything else because some of these are used down here on these ROMs. So the U7 is the RAM. We're not using that at the moment because we're just trying to get the flash. U6 is the 5101 RAM. No, U8. U8 is the 5101 RAM. Which is using U18. Yeah, I don't know that we can. I guess we could just try it, but we're going to need these because they're using it to route some of the signal, like the address and data stuff. I guess you could work all through it and just figure it out. Like over here, it depends on what jumpers are on the board and stuff too. But over here, you know, this wouldn't be needed unless you were using E10 for something. And we're not. We're jumpering over E10. But that's just one part of that chip, you know. So there's other things that will be used for. Okay, and U14, this part wouldn't be needed unless you were using E25. And looking over here, we are not. Okay, well, that's cool. All right, I like it so far. But then we've got this coming over here to E19. Now we're using E19. I'm looking here on the board as I go through it. Yeah, see, we are using E19. So, all right, I'm just going to leave out the display ones, E20, and I'm going to leave out, U20, and I'm going to leave out U12, and I'm going to leave out U14, which is the zero crossing detector. Unless U14 is used down here somewhere. Oh yeah, that was that one we were just looking at. All right, 20 and 12. I think that's all you can leave out. I think the rest of it you need because it's used for various clock signals. To route address lines and stuff for the ROMs. We're going to have to change some of those jumpers and stuff probably anyway whenever we put the new ROMs in. Okay, folks, I've got a power supply, a bench power supply, and I've got a little connector rigged up here with the 12 volt, 5 volt, and a ground. And this isn't the best way to do it. I need to make one that's got a switch where I can just turn it on and off. But, did you see that? It flashed and then went back off. You shouldn't really hot swap it like this. But do as I say, not as I do. I'm just trying to illustrate the point here on video. Isn't the greatest way to do it if you have a test bench. So sometimes it'll stick on like that if you're playing with the power like I'm doing. But each time I do it, it's basically resetting the little quick flicker. And it's off because the CPU is turning it off. Also, if you short pin 39 and pin 40 together, what you are doing is I now have pin 40 low because pin 39 is low. So I'm forcing pin 40 low, which puts the MPU in like where it's basically turned off. And then when I let go of it, it goes back high. So the reset is now 40. This goes back high, and it has started the MPU. The MPU has started reading the game code in this ROM and turned off the LED. So it's just the quickest flicker that's basically, all that's happening is it's just starting to run the code. It's trying to run the first RAM test, which is to check the EPROMs, and it's turning the LED off because it's going to turn it on to communicate with you. right? So all that's going on right now is the CPU has taken control of the LED. But what that means is our CPU is at least somewhat working, our PIA is at least somewhat working, our LED is working. I mean, we knew that because it was turned on, and our ROM is somewhat working. But we don't know, and the reset section is somewhat working. But we don't know if the ROM is correct. We don't know if everything on the PIA works. We don't know if every single address and data line on the CPU works. We just think so. But that first flicker, for it to turn off the LED is the absolute hardest part to repair. So the next thing that it checks is it checks the ROMs. I've only got one in there. This is a 2732, a used one, obviously. I guess they're all used now, right? Unless you find some new old stock ones. It's a 2732 that I've burnt new software on, and I'm going to burn another one for here that is the game-specific software. So on these PCBs, this one is kind of like a generic chip that basically runs all of the like it has the diagnostic code in it. It basically is the bones of the program that runs, because it's all the same. It's telling it how to display numbers. It's telling it what the PIAs are doing and all that. It's like all of the basic code that is the same in every Bally pinball machine, or very similar, right? And then the one that goes up here, sometimes in two different ROMs, like on our original board. Yeah, it had two ROMs. So this is the one that's already in there, and these two were up here. Well, you can combine them into one 2732 and put it here. So both of these can be 2732s or 2532s, but depending on what chip you're using, you have to change the jumpers on the board. So this is a jumper, this is a jumper, this is a jumper. There's some more here. And Bally has released all of that information and tells you every little thing. And it's also just basically in the schematics. If you look, it shows everything. We saw that earlier. All that to say, I've got it jumpered for two 2732s. I burned one already. I'm going to burn the other one. And what that should do is get it to where when we turn it on, it does the quick flicker, which is the CPU turning the light off. And then it will give us one solid flash to let us know that the ROMs are good. It's not doing that yet because we don't even have both of them in there. So that's next. All right, so I've burnt the other ROM, and again, we've got everything jumpered properly. We've got power on it. There's the LED. I'm going to do the reset, basically, by shorting the pin 40 to pin 39. All right, so it's held low right now. So it's as if we have just gave it power. Now, it's hard to understand that. That is actually a flicker and one flash. The flicker part is very confusing. A better way of thinking about it is, because again, as soon as it gets power, the LED is going to be on like this. So a better way of thinking about it is it turns off and then flashes once. Off, flashes once. That is one flash. But the turning off is that when it first comes up, you'll see that light come on and then go off immediately. So the going off, they call it the flicker, right? Because it had a little bit of light and went off. So there's the first flicker. That means that the power is right, the LED's right, it's starting to read this code, and then the one flash is it saying, hey, your ROMs are good. It's doing just a checksum. So we are starting to walk through the code, the flash code. So the next one will be one of these two RAM. So if there is a problem, I'll resist the rest of that. If there is a problem, this one will probably be it. All right, I always get those two confused, but the second one is the 6810, which is just the regular RAM that runs the ROMs and the code. And then this one is the 5101, but I can't remember which one's 2 and which one's 3. Number 2, or so the next one in order, is the 6810. And so it will be the second flash. So if I can do this quick enough, I won't have to use the screwdriver. 1, 2. Okay, so we'll try it again. I didn't go high enough. I really shouldn't be doing it this way. I'm trying to basically hot swap the power. The problem is whenever if you pull the connector off and then put it back on, you're giving it a very weird not just switching the power on. You're giving it a little bit at a time, and it's not happy with that. Now I don't have the 43 wired up to it, so I'm not running the risk of that, but 1, 2. The reason that it waits a little bit before it does the second one is because the way that it checks the 6810 is it does like 36,000 math computations or something like that. So it goes to the first little bit or whatever, and it writes a number in it, and then it says what number is written in bit 1, and it reads it back, and then it goes to the second bit and it writes a number in it. It says what number is written in bit 2, and it goes all the way through, and it's like 36,000 bits or something like that. So it's doing a ton of math, and of course it's doing it at clock speed. So it's just doing so much math that it actually takes a little while for that test. It checks the ROMs for the first flash really quick. The math that it needs to fully check this RAM takes a lot longer. Now if you're doing this and you're trying to repair one and you're not getting that second flash, it could be this chip too, because a lot of the signals to these two chips in particular come down through here. So you can see that I actually had to repair one. There was a connection through from here over to here, and then it comes up here, and then comes up to here. So some of the connections for the 5101 are also the connections for the 6810. So if you don't get that second flash, yeah, it's this chip, but it could be one of the signal lines running through a really screwed up socket here like we've got, where it was just trashed. It's very common for this to have serious problems. But the third flash, the next one, is in fact that one. Now keep in mind, we don't even have the 555 in yet. We don't even have this other PIA in yet. And we don't have this one chip up here that we know for sure U20 is only used for the displays. So it's an output. You don't actually need it to boot everything. Which just goes to show you, if you have a problem with this, it's not that, it's not that, and it's not that. It's, something else. All right, so let me put a 5101 in and see if we can get our third flash. All right, so got the 5101 in. See if I can hot swap it. 1, 2, 3. Bam! That's what you want. Let's try it one more time. 1, 2, 3. So there's a little pause between this before the second one because it's got to do all that math. And then it just told us the third one's good. If you cannot get that third flash, if there's any corrosion at all, you've got a problem with these lines that hang down low on the board. So you've got these right here and these here that jump over to here. There's also some here beside it that connect to this chip and then go up here to a couple things. All right. So you've got a bad trace. If you look in the schematics and check your address lines, you can just check, like A3 and see where it is over here on the ROM, and just see if the A3 pin on the 5101 is connected to the A3 pin on the ROM, and on and on and on. And if every single one of them is connected where it should be, it should work. If it still doesn't work, you've probably got a couple of the lines connected somewhere. Usually, though, if you've got a couple address lines shorted together or a couple data lines shorted together, you won't even get the first flicker on the ROM because it can't read the ROM because they've got a couple address lines shorted together. So that's another thing you can try if you just can't get it to work. And this is, I realize by this time, this is for people that are just wanting to tinker with these old boards, because you can buy a brand new board, and that's what 99% of people do now. But if you've got one and you cannot figure it out, check all the address lines and see if any of them are shorted to each other. So is A3 shorted to A5? Is A3 shorted to A6? Is A3 shorted to A7? And then check all the data lines. Is D1 shorted to D2? Is D1 shorted to D3? Is D1 shorted to D4? On and on it goes. Okay, so that's 3. Now the fourth flash is this 6810, the 6821 that goes here, and the fifth flash is the 6821 that's here. It's just a more extensive test. So whenever I put the 6821 in here, we should get our fourth and then our fifth flashes. So I've installed a 6821 here. Usually you don't get any trouble out of it as long as that thing's good. The socket's usually fine because it's nowhere near the corrosion zone. And this one, by the time you get up to this flash, you've kind of tested it a little bit with this LED, So let's see what we get. 1, 2, 3, 4, 5. Okay. All right. So we're doing really good. All right, so the 6th flash is checking this display interrupt generator, and it's just a line that it needs to make the displays work. And that, of course, is the 555 timer. It's very common on this for the timer to actually be fine, but for this cap or this resistor to be all corroded, so one of the legs isn't working right, just because of the corrosion stuff. But, you know, on ours we had a different problem where we had fried every single chip on the board. Let's see what we get. 1, 2, 3, 4, 5, 6. All right, so we've got all 6. All right, now the 7th one we can't test because the 7th one is the one that caused the whole freaking problem. The 7th one is the zero crossing detector, which was the solenoid voltage into the board. You can do some little cheat stuff and mess around with a 5 here or something. But the way we're going to test it is we're going to test it the old-fashioned way. We're just going to put it in the cabinet and see if the thing will finally boot up. All right, folks, so we still got to do some work in the cabinet. We've got to repin some connectors and stuff before we actually try it in there. But I wanted to show this. David sent us this little IC pin straightener in. That's pretty cool. So basically, whenever you buy new ICs, the legs are all splayed out usually, and this little thing is like a little cruncher. And it does the wide ones and the thin ones. So you take, I don't know if I have one that's, like that one's kind of stretched out. This is a screwed up one. This is one of the ones that was burnt up. Put it in there, squeeze it, and now they're all straight. That's pretty cool. So thank you, David. We appreciate that. But leave your comments down below. Let us know what you think. I think this one is a good little base, and we worked through fixing every little part of it. We'll keep working through the pinball machine on the next video, and we still have to mess with the displays. We still have to mess with the lights, check all the switches, all of that crap. So we got a long way to go on this thing still. But I hope you enjoyed it. We will see you on the next one. Now, if you want to see us do more of this board repair crap, if you're not completely tired of it, check out this video. Good old Bally.